Welcome back to Easy Learning. Today we are going to discuss in detail about our chapter 2 polynomials. Before moving on to our topic, if you haven't subscribed my channel yet, please subscribe and click the bell button. Okay, let's move on to our subject, polynomials. You know what is a polynomial? Polynomial. It has two terms, polynomial. Before moving on to the details of it, let's discuss in detail about what a polynomial is. Polynomial. Poly means many. Nomial means terms. So in general, polynomial is an algebraic expression which has many terms. Okay, so we need to understand what are terms. Terms means, I'll give you an example. Suppose we have an expression 3x square plus 5x plus 2. This is an algebraic expression. Okay, here this 3x square is called a term. 5x is another term and 2 is another term. So I hope now you understand what a term is. Terms. So polynomial is an algebraic expression with many terms. In this example, you can see there are 3 terms in this algebraic expression. So we can call this as a polynomial. Clear? There are many types of polynomials. Don't think that you may have an assumption that polynomials will be having many terms. 7, if I write 7, 7 is also a polynomial. If I write 2x, 2x is another polynomial. Okay, 2x plus 2, this is also a polynomial. The difference is, in this there is only one term. There is only one term. So we call this a monomial. We call this a monomial. Monomial is a polynomial with one term. If we make it 2x plus 2, we can see that there are 2 terms. 2x and 2 are 2 terms. So what we call this? This will be a binomial. This will be a binomial. For example, 2x square plus 2x plus 2. In this example, we can see there are 3 terms in this expression. So what we will call this expression? It is a trinomial. Tri means 3, so trinomial. Understood? So polynomials are of different types. A polynomial can be with 1 term, 2 terms, 3 terms, or many terms. But in this module, in this chapter of your grade 10 polynomial, we are mostly dealing with 3 types of polynomials. That is a linear polynomial, a quadratic polynomial, and a cubic polynomial. Okay, a linear polynomial is a polynomial with degree 1. So we need to understand what degree is. A polynomial can be with one variable or many variables. Suppose x square plus 2x plus 3 is a polynomial with only one variable x. Okay, x square y plus y square x plus 2, this is also a polynomial, but we have 2 variables in this. So polynomials can be with one variable or many variables. Another example is x square y z plus y xy z plus 10. This is also another polynomial with 3 terms. Is it clear? So these are all polynomials, but in this chapter we are dealing with polynomials with one variable, single variable. So we need to understand about degree of a polynomial. This is a polynomial. For example, let a polynomial p of x. Okay, we are writing a polynomial. P of x means polynomial with variable x. Okay, x plus 5 is a polynomial. What is the power of x in this polynomial? It is 1, isn't it? So degree of this polynomial is 1. Another example, x square plus 2x plus 5. What will be the degree of this polynomial? Degree of this polynomial is the highest exponent of x, or the highest power of x will be the degree of that polynomial. So degree of this polynomial is, which is the highest exponent. Here the exponent is 2, here it is 1. 5 means 5x raised to 0. X raised to 0 is 1. That's why we are just writing 5. Okay. X raised to 0 is 1. So we are just writing 5 into x raised to 0. So which exponent is the highest in this polynomial? X raised to 2. 2 is the highest exponent or power. So the degree of this polynomial will be 2. Another example is x cube plus 2x square plus 4x plus 10. What will be the degree of this polynomial? We can say that the highest exponent is 3. So degree will be what? Degree is 3. This is the way we have to understand about degree of the polynomials. Now you can easily write the degrees of polynomials. Is it clear? Okay, let's move on to our next topic, that is different types of polynomials which we are dealing with in this chapter. Okay, so degree is the highest power of variable x. We already studied about that. Now, polynomial's general form is constant into variable raised to whole number. That's the main thing you have to remember. Whenever we are writing a polynomial, it should be in the form a constant into a variable raised to whole number. For example, 2x. This is a polynomial. The power of x is 1. 1 is a whole number. Or simply, if you are simply writing x square, this is also a polynomial. X square means 1 into x square. So this is also of the general form a constant into variable raised to whole number. Okay. Let me ask you, x raised to minus 5 is a polynomial or not? X raised to minus 5 is a polynomial or not? No, it is not a polynomial because the power of x is minus 5. Minus 5 is not a whole number. So x raised to minus 5 is not a polynomial. Another example is root x is a polynomial or not? Root x. Root x is x raised to 1 by 2. This is not a polynomial because the power of x is 1 by 2. 1 by 2 is not a whole number. So when you are writing a polynomial, when you get a question regarding polynomial, first thing you have to notice whether it is of this general form or not. It should be in the form constant into variable raised to whole number. Okay, so let's move on to our different types of polynomials. In this we are mainly dealing with 3 types of polynomials, that is linear polynomial, quadratic polynomial and cubic polynomial. Okay, linear polynomials are those polynomials with degree 1. Now you already know how to find the degree of a polynomial. So those polynomials with degree 1 are called linear polynomial. Then what will be quadratic polynomial? Polynomials with degree 2 are called quadratic polynomial, and polynomials with degree 3 are called cubic polynomial. Okay, so we'll write the general form of these polynomials. Linear polynomial, in general we can write it is of the form ax plus b. Ax plus b. What is the power of x in this? It is 1. So linear polynomials are polynomials with degree 1. Also, a should not be equal to 0. A not equal to 0. This is a general form of a linear polynomial. Linear polynomial is of the form ax plus b, where a not equal to 0. Polynomials with degree 1 are called linear polynomial. Degree equals 1 are called linear polynomial. Now, next type of polynomials are quadratic polynomial. The degree of quadratic polynomials are 2. So, what will be the general form of quadratic polynomial? It is ax square. Highest power of x must be 2. So, ax square plus bx plus c, where a not equal to 0. Degree equals 2. Clear? Then what will be the cubic polynomial's general form? Ax cube plus bx square plus cx plus d, where a not equal to 0. Degree equals 3. A should not be equal to 0. If a becomes 0, 0 into x, then whole term will become 0. So, a should never be equal to 0. B and all other terms can be 0. That's not a problem. If we get ax is a polynomial or ax square is a polynomial, other terms are 0, that doesn't matter. But a should never be equal to 0. So, these are the three types of linear polynomial, quadratic polynomial and cubic polynomial. Is it clear? Okay, now let's discuss about 0 of a polynomial. 0 of a polynomial is the value of x at which our polynomial becomes 0. Okay, I'll tell you an example. Suppose we have a polynomial p of x equals 2x plus 5. We need to calculate the value of x at which this p of x will become 0. So what we have to do? First we have to equate this p of x with 0. Okay, our p of x is 2x plus 5. So 2x plus 5 equals 0. We need to calculate the value of x at which this equation will become 0. So what will be the value of x? 2x equals minus 5. Okay, x equals minus 5 by 2. Isn't it? When x becomes minus 5 by 2, this equation will become 0. That means our p of x will become 0 when x takes a value minus 5 by 2. So this value of x is called 0 of a polynomial. Value of x at which our polynomial becomes 0 is called 0 of a polynomial. So in this we have a graphical representation of 0 of polynomial also. We are moving on to that. Then it will be more clear to you how to find the 0 of a polynomial. Our next section is the geometrical meaning of 0 of a polynomial, or geometrical means graphical representation. You know how to draw the graph, right? We already done in our previous classes how to plot a graph. So now we are going to plot the graph to find the exact meaning of 0 of a polynomial. Suppose we have a polynomial p of x equals, say, x plus 5. Okay, we know what is the 0 of polynomial. 0 of polynomial is the value of x at which this polynomial will become 0. In the algebraic method, if you are doing in the algebraic method, first we have to equate it with 0. Then this polynomial will become 0 when x equals minus 5. Isn't it? So we know that 0 of this polynomial is minus 5. Value of x at which this polynomial become 0 is minus 5. So 0 of this polynomial is minus 5. We know by using our algebraic method. Now what we are going to do, we are going to graphically analyze this result. So I am going to draw a graph. Okay, this is our x-axis and this is our y-axis. Clear? So our y will be p of x. We can just equate y equals, I'll write it here. y equals p of x. So our x-axis is this and y-axis. 1, 2, 3, 4, 5. 1, 2, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Here also minus 1, minus 2, minus 3, minus 4, minus 5. Okay. Okay. To plot this graph, we need to get the values, right? So what will be the values? I'll write it here. X, y. When x equals 0, now our y equals x plus 5, right? When x equals 0, y will be 5. Just substitution. When x equals 0, y equals 0 plus 5 equals 5. When y equals 0, we just need to get 2 points to plot the graph. When y equals 0, then y equals 0 if y equals 0, x equals minus 5. Isn't it? So we got the 2 points to plot the graph. So first point is 0, 0, minus 5. Okay, this is 0, minus 5. Next point is 5, 0. 5, 0. So this will be the second point. 0, 5. Okay, 0, 5 and 0, minus 5. And our graph will be a straight line cutting this. Okay, cutting these 2 points. So what will be our 0 of this polynomial? 0 of polynomial is the point at which our y equals 0. In this, our y value is 0, right? Sorry, I wrote it in the wrong way. Minus 5, 0 and 0, 5. Okay. The point at which our y becomes 0 at this point. So what is the value of x in this point? At this point, the value of x is minus 5. And this point, value of x is 0. And value of y is 5. So what we have to understand? We have to identify the area at which our line cuts the x-axis. Our line cuts the x-axis at x equals minus 5. So 0 of this polynomial is x equals minus 5. Okay, 0 of this polynomial is x equals minus. So we need to understand the coordinate at which our graph of p of x cuts the x-axis is the 0 of that polynomial. So in this diagram, in this graph, our line cuts only at this point. So the 0 of this polynomial is minus 5. Value of x at this point is minus 5. So 0 of this polynomial is minus 5. We already calculated by using our algebraic method. The 0 of this polynomial is x equals minus 5. So both are same. This is the graphical representation. This is our algebraic representation. So now you know that the point of x coordinate at which our graph p of x cuts the x-axis is the 0 of that polynomial. Suppose we may get a graph like this. This is also a graph. It's a parabola. It's also a graph. Here, and how many points the line cuts the x-axis? One point is this, another point is this. Here are 2 points. This line cuts the x-axis. That means there will be 2 zeros of polynomial for this graph. There will be an algebraic expression for this graph. So there will be 2 zeros of polynomial for this graph. Suppose if you are drawing a sine wave. How many times a graph cuts the x-axis? 1, 2, 3, 4, 5. So how many zeros of polynomial will be there for this graph? There will be 5 zeros of polynomial for this graph. The only thing you have to focus is how many times that line cuts our x-axis. That is the only thing we need to focus. Suppose if you get a graph like this, is this line cutting the x-axis? No, this line is not cutting the x-axis. So there is no zeros of polynomial. This is the way we have to understand how many zeros of polynomial will be there for this graph. 0, because this graph is not cutting our x-axis. So there will be no zero of polynomial for this graph. You need to look at the points. How many points this line cuts the x-axis? That is the zero of that polynomial. If the graph cuts 2 times, then there will be 2 zeros of polynomial. If it cuts 10 times, there will be 10 zeros of polynomial. So this is a way you have to draw the geometrical or graphical representation of a polynomial and identify the zeros of a polynomial. Is it clear? Okay, let's do some problems and it will be more clear. So let's generalize the whole concept of graphical representation of zero of a polynomial or geometrical meaning of zero of polynomial. The first thing is, for any polynomial p of x with a degree n, there will be at most n points where the graph of p of x will intersect the x-axis. That means, now let's consider about a linear polynomial. You know what a linear polynomial is? Linear polynomial is of the form, what is the general form of linear polynomial? Ax plus b, where a not equal to 0. Okay. What is the degree of this linear polynomial? Degree of linear polynomial is 1. So, in a general form, for any polynomial p of x with degree n, if we are coming to linear polynomial, degree of this linear polynomial is 1. So, the graph of linear polynomial will intersect the x-axis at 1 point, at most 1 point. Okay, if we are drawing a graph, what we considered for our example is a linear polynomial. X plus 5 is a linear polynomial. How many points did it intersect the x-axis? It intersected at 1 point only. For a linear polynomial with degree 1, for any linear polynomial, the degree is 1. For linear polynomial, the graph of the linear polynomial will intersect the x-axis at only 1 point. Think about a quadratic polynomial. We know that quadratic polynomials ax square plus bx plus c, where a not equal to 0, the degree is 2, because the highest exponent of x is 2, degree of quadratic polynomial is 2. For any quadratic polynomial, the graph of that polynomial will intersect our x-axis at most 2 points. Okay, maximum of 2 points it will intersect. That means there will be maximum of 2 zeros of polynomial for a quadratic polynomial, because it will intersect at most 2 points at our x-axis, or a minimum of 0. Okay, maximum is 2 or a minimum is 0. Then consider about a cubic polynomial. What's the degree of a cubic polynomial? Degree of cubic polynomial is 3, isn't it? So how many points maximum it will intersect our x-axis? It will intersect at 3 points. You just think about the degree and connect it with our zeros of a polynomial. Then it will be more clear. Okay, no need to think a lot about it. You know what is a degree of a polynomial is, and you need to know how to connect the degree and zeros of a polynomial. I have clearly written general form. Okay, I have clearly written general form. For any polynomial p of x with degree n, it will intersect the x-axis at most n points, maximum n points. Degree is n, it will intersect at most n points. And you know what is number of zeros of p of x? Number of zeros of p of x is the number of points at which the graph of p of x intersects x-axis. That you already know. You can just note it down so it will be more clear. Okay, for linear polynomial there will be at most 1 point. Okay, for quadratic at most 2 points. Just connect it with the degree and zeros of a polynomial. Okay, this is the concept. Now let's do some problems related to geometrical meaning or graphical representation of polynomial. That will be more clear. We need to find just how many zeros will be there. So just looking at the graph itself, we can identify how many points it is cutting the x-axis. Then it will be the number of zeros. Okay, let's do some problem. It will be more clear then. This is an example in your textbook, example 1. We need to find the number of zeros of this p of x. Okay. In this graph, how many points are there in which the graph intersects the x-axis? There is only 1 point, isn't it? So how many zeros will be there? Only 1 0. Here there are 2 points where it intersects the x-axis, so there are 2 zeros. Is it clear? Then now tell me this. How many points? 1, 2, 3. Then how many zeros will be there? 3 zeros. In this, how many points it intersects the x-axis? There is only 1 point where it intersects the x-axis. This is y-axis. So don't be confused. You need to look only the x-axis. How many points are there? Only 1 point. So how many zeros? 1 0. And what about this? This cutting the y-axis, then it comes and cuts the x-axis. So how many zeros are there? Only 1 0 is there. 1 0 of a polynomial. And what about this? How many points it intersects in our x-axis? 1, okay, 2, 3, and 4. So how many zeros are there? 4 zeros are there for this p of x. Is it clear? This is our exercise 2.1. We need to find the number of zeros for each of this graph of p of x. So first question is this: how many zeros are there in this graph? Is there any zero? Is there any line cutting your x-axis? No. So there are no zeros. There is no line cutting our x-axis. Question number 2. How many points it cuts our x-axis? Only 1 point. So how many zeros are there? 1 0. Okay. What about this? How many points? 1, 2, 3. So how many zeros are there? 3 zeros of polynomial are there. What about this? It cuts 2 times. 1, 2. 1, 2. So 2 zeros. Whereas this, it cuts 1, 2, 3, 4. Isn't it? 1, 2, 3, 4. So there are 4 zeros. Whereas in this, 1, 2, 3. Okay. So 3 zeros. Very easy. Is it clear?